You're just testing the sound. We'll do this one quickly. May involve GPT-5 as well. Currently we're just doing normal testing. Just check the audio. Checking the audio. Yeah, we're using the correct microphone. That's good. Shall we bring another bot or just keep using this one? Okay, we need to patch the self-testing. Yeah, we have an agent doing that. So just keep going with it. So why the testing is breaking? It's not passing the test. Why? Hey, want to patch the code? Yes. Okay, we had all the tests passed. Okay, just having this warning, but no errors. Okay, let's just play this one.
Absolutely, I can help with that. Looking at your current simulation, it's clear you've put a lot of effort into making the experience interactive and educational. However, if the goal is to make the simulation more scientifically accurate, there are a few areas where improvements could be made. First, the anatomical representation is quite simplified, which is great for accessibility but may not fully capture the complexity of penile anatomy and physiology. For example, the simulation currently treats the corpora cavernosa and corpus spongiosum as simple geometric shapes, and the blood flow is visualized as a color fill. In reality, the process of erection involves a much more intricate network of blood vessels, smooth muscle relaxation, and the role of the tunica albuginea in trapping blood. You might consider adding more detail to the vascular structures, perhaps showing the heliciny arteries, veins, and the tunica's compressive effect during erection. The animation of urination and ejaculation is also quite linear, with particles moving along a fixed path. In the human body, these processes involve coordinated muscle contractions, like the bulbospongiosus muscle during ejaculation, and sphincter control, which could be represented with more dynamic animations or even a stepwise flow. For example, you could animate the rhythmic contractions that propel semen, or show the bladder sphincter closing during arousal to prevent urine flow. Another area for scientific accuracy is the interaction between arousal and urination. The simulation correctly prevents urination during arousal, but in reality, this is due to the internal urethral sphincter closing, a detail that could be visualized or explained in the UI. Similarly, the simulation could benefit from showing the refractory period after ejaculation, where the penis returns to a flaccid state and cannot immediately become aroused again. From a physiological perspective, the simulation could also include the role of nerve signals, hormones, like nitric oxide for vasodilation, and feedback mechanisms. Even simple visual cues or tooltips explaining these processes as the user interacts would add a lot of educational value. Finally, the sound effects are a fun touch, but for scientific accuracy, you might want to ensure they're subtle and not cartoonish, as real physiological processes are mostly silent. In summary, while your simulation is engaging and covers the basics, adding more anatomical detail, dynamic muscle and vascular animations, and physiological explanations would make it more scientifically robust. If you'd like, I can suggest specific code or UI changes to address any of these points.
Okay, let's go back to the code. No, we don't need the instructions. We currently have what's it, 1,000, just over 1,000 lines of code. Okay, this is a problem with Copilot, is that if I try reverting to previous I'm trying to revert back. I have to start a new chat. Shall we try GPT-5? Don't know. What do you think? What do you think? I might get back to this one at the later stage. I'll give it to GPT-5. Well, let's share AI Studio, so let's bring a prompt engineer real quick. I'll share a screen. Okay, can you describe what's on the screen real quick? We are developing this web application at the moment, but we need the summary of what's currently going on, and then we go over how to improve it as well.
Okay, the screen displays an interactive simulation titled Penis Function. It uses abstract shapes to represent different parts and processes like arousal, ejaculation, and urination. The buttons at the bottom allow you to control the simulation, triggering different functions and resetting the demo, with options for sound and other settings.
Okay, and how realistic this simulation is and how scientifically accurate it is?
Well, based on the visual style and the simple buttons, it seems to be an abstract simulation, focusing on demonstrating the basic functions rather than being anatomically realistic or scientifically detailed. It's more for conceptual understanding.
Again, how would you go about improving it? The reasoning model. So what's thinking for? Wait, is it? I didn't think it was. It's thinking forever. It seemed to have stopped. Okay, are you there? It's thinking again.
To improve the simulation, you could consider adding more detailed anatomical representations, incorporating labels or explanations for the different parts and functions, and potentially increasing the complexity or interactivity to provide a more comprehensive understanding. Making it visually more informative could greatly enhance the user experience.
Okay, can you elaborate on that? We would like to actually send a standalone brief for a developer, for an experienced developer.
Sure. To improve
Okay, now it starts hallucinating. As in, no, there's something wrong with the implementation of this thing. Keep going.
Sure. To improve the simulation, you could focus on several areas. First, enhancing the visuals to be more realistic and anatomical.
Get this. Yeah, it's actually generated there. Do I need to like generate the whole thing and then play it all together or something?
Sure. To improve the simulation, you could focus on several areas. First, enhancing the visuals to be more realistic and anatomically accurate would make it more informative. Second, integrating labels, tooltips, and clear explanations for each component and process would greatly enhance the educational value. Third, improving the interactivity, perhaps allowing users to manipulate different parts or explore various scenarios, would make the experience more engaging. Finally, ensuring a user-friendly interface with clear controls and smooth functionality is crucial for a positive user experience.
Okay, so can you generate the entire brief for the developer? We want to redo this code from scratch, and we will be using an experienced developer. So how would you go about prompting them? Can you just generate the final prompt? Okay, it will generate it first, then we will. Yeah, otherwise there's something wrong with the audio on the page. So that's AI Studio, almost 1 gigabyte in memory of the browser. But it's generating a standalone brief. So should we use GPT-5 for it? Let's see how we go. Okay, so I have the brief. We'll read it. We'll read it out loud real quick.
Okay, here is a brief for the developer. Project brief: Interactive Penis Function Simulation. Objective: recreate and enhance the existing interactive penis function simulation from scratch. The goal is to provide a visually realistic, anatomically accurate, and educational experience with clear labeling and improved interactivity. Key improvements required. 1. Enhance visual realism and anatomical accuracy. 2. Clear labeling and detailed explanations for all components and functions. 3. Improved interactivity allowing user exploration. 4. User-friendly interface design. Key functionalities to include arousal/erection, ejaculation simulation, urination simulation, reset function, sound options, and additional settings like tunica albuginea and glans gradient controls. The final product should be a compelling and informative simulation suitable for educational purposes.
Okay, we might want to expand on that. We'll turn it into info. Okay, I want to rewrite this standalone. Just use one of the simpler models. Hey, can we rewrite and update this brief, make it standalone so we can send it to the developer directly?
Here is a revised, standalone project brief suitable for sending directly to a developer.
Okay, we don't want to read that because it's a lot of bullet points. Can you summarize in conversational language without any bullet points?
This project is about creating a new and improved interactive simulation that demonstrates penis function. The goal is to make it visually realistic and anatomically accurate, while also being educational and easy to use. The simulation should clearly label all parts and provide detailed explanations, making it simple for users to explore and understand how everything works. Key features will include simulating arousal and erection, urination, and a reset option, along with sound effects and adjustable settings like controls for the tunica albuginea and glans gradient. The final product should be engaging, informative, and suitable for educational purposes.
Can you explain this too for the developer?
For the developer, the tunica albuginea refers to the tough, fibrous layer of connective tissue that surrounds the corpora cavernosa of the penis. In the simulation, you should provide controls that allow users to adjust properties of the tunica albuginea, such as its thickness or elasticity, to help illustrate its role in erection mechanics and penile rigidity. The glans gradient refers to the gradual change in color, texture, or other visual properties from the shaft to the glans, the head of the penis. The simulation should include a setting that lets users adjust this gradient, making the transition between the shaft and glans more or less pronounced. This helps users visualize anatomical differences and enhances the realism of the simulation.
Should we give it a different model? Could also use let's do a thinking dialogue.
Interactive penis function simulation. Objective: develop a new visually realistic, anatomically accurate, and highly interactive simulation of penis function.
Why can't just
Educational use.
use?
The simulation should provide clear labeling, intuitive user.
Oh, need to mute the site. Simulation takes forever to generate. Why? Something wrong. This is 2.5 flash. It's some sort of reasoning model. It takes forever to generate. Not sure the GPT-4, like in which mode should we be using it in? So it's not as expensive as Sonnet 3.7 thinking. Pretty sure if I send it to shall we generate the template? Can we essentially, we essentially want to redo, we want to generate another HTML file. So essentially we want to take what's currently in the index HTML and redo it from scratch, redo that code from scratch. We have a detailed description, a brief for the developer in the info file. So maybe we can generate a template for the new HTML file.
Based on your project brief and requirements in the info file, here's a plan for generating a new HTML template for the interactive penis function simulation. Key features to include: visually realistic, anatomically accurate canvas-based simulation, clear labeling of all anatomical parts with tooltips or overlays, controls for arousal/erection, urination, reset, sound toggle, tunica albuginea properties, thickness/elasticity, glans gradient adjustment. User-friendly, accessible UI, educational content/sections explaining anatomy and function. Modern, clean design, using only HTML5, CSS, and Vanilla JS. Template structure: title, meta, fonts, styles, header/title, main simulation area, canvas, controls panel.
We don't want to read that, but we have a template for it. Is we can't even move to, it says changing the chat mode to edit. Will end your current edit session. Would you like to change the chat mode? I don't know why is it a problem, because I can move between ask and agent. I don't know, is that meant to work like that, or? Okay, so in the chat, we want you to just to explain what's going on and what needs to be done. So essentially, we have an older code in the index HTML. Then we have the info, that's the developer brief of what we actually want. And now we have the new index HTML, which is the template for the new code that we actually need working and running. We want to continue developing it so everything is working correctly. We need everything essentially redone from scratch, so we are not taking code, we're not taking any of the old code. We need to redo everything from scratch. So can you generate the complete and working code based on what's discussed and what's the content in the other files?
Enable GPT-5 preview for all clients. Enable access to the latest GPT-5 model from OpenAI.
Okay, that's the first time we're using it. Well, it said 4.1 is hosted on GitHub Azure tenant when used. Yeah, it's not very useful information. I'm not sure if it's actually doing anything. No, it is writing code. It's the first time we are using GPT-5. So I did another 300 lines. Edit key shortcuts, keyboard shortcuts. Yeah, but it's actually kept the same thing. Okay, this is what yeah, it made this too more realistic. We have sound. Okay. Yeah, the sound is not great. It's not very correct, is it? No, because, well, well, it's not necessarily much better than what we had before, so that's GPT-5. And did it cost us anything? Doesn't look like. Sometimes it's not updating straight away. Where's the... I get rid of the demo mode. Get rid of the demo mode. And making a few suggestions. It seems to be charging me premium requests, which I don't know if it forget it's gonna update later or else. Currently it's swapping the visuals to higher anatomical fidelity, the cross-sectional view, so on and so forth. Cross-section. The cross-section is not very useful, is it? What? Oh, come on. The sound is annoying. The sound is annoying. This keyboard shortcuts not indicated in the... Okay, no, now it is charging me premium requests. Can you explain conversational response? Make it fun. Why does the cross section look so bad?
Absolutely. Here's a fun, conversational explanation. What's going on with the cross-section? So, you press the button and voila, a cross-section pops up in the top right. But, it kind of looks like two red blobs, a pink circle, and a little gray dot, all floating in a white box. Not exactly the Mona Lisa of anatomy, right? Why does it look like that? The cross-section is a super simplified cartoon view, two big circles for the corpora cavernosa, the erectile chambers, a smaller one for the corpus spongiosum, the ventral tissue, and a tiny circle for the urethra. They're just circles, not squished or shaped to fit together like in a real anatomical cross-section. There's no connective tissue, no skin, no shading, and the arrangement is a bit bubble tea rather than medical textbook. The tunica outline is just a thick stroke around each circle, not a continuous anatomical envelope. How could it be improved? Make the corpora cavernosa more oval and touching, not just two circles. Have the corpus spongiosum hug the urethra and sit below the cavernosa, not just float. Draw a single, continuous tunica outline around all three chambers, not three separate outlines. Add subtle shading, maybe even a hint of skin or fascia. Maybe label the parts directly in the inset. In short, the cross-section is anatomy for stick figures. It's functional, but not pretty. If you want, I can upgrade it to look more like a real anatomical cross-section, just say the word.
Okay, can you also explain why do we have the tunica? Why do we have the two sliders? Can you just do a conversational review? We don't need them.
Absolutely. Here's a conversational review of your simulation, focusing on the tunica, the two sliders, and the overall interactive experience. Let's talk about the simulation. You've got a pretty cool interactive penis anatomy simulator here. It's not just a static diagram, it's alive. You can poke, prod, and play with it using the controls and sliders. But what's the deal with those two mysterious sliders at the bottom? And what's this tunica thing anyway? Why do we have the tunica albuginea? Think of the tunica albuginea as the superhero suit of the penis. It's a tough, stretchy layer that wraps around the erectile chambers, corpora cavernosa. When you get aroused, blood rushes in, and the tunica keeps everything contained, making the penis rigid. If the tunica is thick and strong, the erection is firmer and stands up straighter. If it's thin or stretchy, the erection is softer and bends more. So, in the simulation, adjusting the tunica thickness slider lets you see how a tougher suit changes the shape, angle, and rigidity of the erection. It's a hands-on way to understand why this layer is so important. What do the two sliders do? Tunica albuginea thickness slider asterisk. Slide it left for a thinner, stretchier tunica, softer, more flexible erections. Slide it right for a thicker, tougher tunica, firmer, more upright erections. You'll see the shaft outline get thicker and the erection angle change as you adjust it. Glans gradient slider asterisk. This one's all about looks. Slide it to make the color and texture transition between the shaft and the glans, the head, more or less pronounced. Want a sharp color change? Slide it up. Prefer a subtle, blended look? Slide it down. It helps you. It looks like your question got cut off after how Absolutely. Let's make this fun and clear. So, you want to swap out the two sliders, tunica thickness and glands gradient, for a single dysfunction slider? That's a great idea. Here's why it's cool. Why a dysfunction slider? Instead of fiddling with technical anatomy details, you get one big picture slider. Slide it left for healthy function, everything's working as nature intended. Slide it right, and you introduce more and more erectile dysfunction. The erection gets weaker, softer, maybe droopier. The angle doesn't rise as much. The cross-section might show less blood in the erectile chambers. Maybe even the urination or ejaculation animations change a bit. It's like a realism dial for how well things are working. Super intuitive, super educational, and a little bit cheeky. Why is this fun? Instant feedback asterisk, you see the effect right away, no need to be an anatomy expert. Relatable asterisk, everyone's heard of dysfunction, but not everyone knows what a tunica is. Great for teaching asterisk, you can demonstrate the spectrum from healthy to impaired function in a single gesture. What would change in the code? The two old sliders disappear. A new slider labeled erectile dysfunction, or just function, appears. The simulation uses this value to adjust rigidity, angle, and maybe even color or animation speed. The educational text updates to explain what the slider does. In summary, a dysfunction slider makes the simulation more approachable and fun. Just slide to see what happens when things aren't working 100%. Want me to generate the code for this new slider and update the simulation accordingly? Absolutely. Here's how we'll do it. I'll update your code step by step, one logical change at a time. After each change, I'll give you a fun, conversational summary in the chat of exactly what was changed and why. This way, you can follow along, learn, and give feedback or ask for tweaks at each step. Let's get started. Step 1. Remove the two old sliders, tunica albuginea thickness and glands gradient, from the controls and state, asterisk asterisk. Ready? I'll make this change now. Made changes. Step 1 complete. I removed the two old sliders, tunica albuginea thickness and glands gradient, from the controls area and from the simulation state. Here's what I'll do, step by step. Fix the animation visibility issue. The canvas is black, but the shaft and anatomy aren't showing up. Add the new dysfunction slider to the controls, wire it to state, and update the simulation so the slider actually affects erection quality and animation. I'll describe each change in plain, standalone language after making it. Let's start with the animation visibility fix. Made changes. Step 1 complete. I changed the simulation area's background from black, number 080000, to white, #FFF. Now,
So after removing 2 sliders, yeah, we're having other issues. Seem to be on it. Some variables that we were controlling using sliders, now we just need the fixed value, some constants, I would imagine. Yeah, might need some. Okay, we started having trouble after removing the 2 previous sliders. Hey, can you check the image attached? The animations seem to be wrong. We seem to have, by mistake, removed some important code.
You're right. Based on your screenshot and the code, here's what happened. The animation and shaft are missing because the arousal logic in the animation loop still references the old tunica thickness variable for erection dynamics and stiffness, which no longer exists.
Okay, so can we fix the code? The cross section is kind of useless at the moment. That's what the previous version that we had. Yet the new one is better. Yeah, the sound and the animation, we need the
Summarized
demo
conversation
mode.
history. Made changes. The animation loop and arousal logic have been fixed to use the new dysfunction state, replacing all references to the removed tunica thickness variable. The shaft and animation should now be visible and respond to the dysfunction slider and arousal controls. Let me know if the simulation is now working as expected or if you need further adjustments.
Okay, it's not working well. It used to work better before. Before we removed the previous 2 sliders, I don't know what happened, but yeah, if we can add some troubleshooting, some outputs into the code. So
To
let me
troubleshoot and
finish.
improve the simulation, let's add a simple on-screen debug panel that shows the current state variables, arousal, urination, ejaculation, arousal level, etc., in real time. This will help you see if the state is updating as expected and quickly spot issues. I'll add a floating debug box in the bottom right corner that updates every frame. Made changes. A floating debug panel has been added to the bottom right corner of the simulation. It displays key state variables, arousal, urination, ejaculation, arousal level, etc. in real.
Okay, I just realized we made a mistake. We were updating the wrong code. You don't need the copilot instructions. Rivet. Yeah, we'll have everything eventually deployed on BioniChaos.com. How's this a dysfunction? Okay, can we double check the angles, the trajectory and stuff like that, the angles? So currently in the browser state doesn't look right. Can you check the code? It was working better before. Meant to be a keyboard shortcuts as well.
Made changes. The shaft angle and trajectory logic have been updated for more realistic behavior. The angle now interpolates from a downward, flaccid, position to a healthy upward angle for full erection, with dysfunction causing a droopier result even when aroused. You can enable geometry debug logs by running window.debug_geom equals true in your browser console. Try interacting with the simulation and let me know if the angles and movement look more natural now.
Do we really need that? Debug geom. How does that debug geom actually works? What do I need to? I need to enter a different URL, do I?
You do not need to change the URL. To enable geometry debug logging, open your browser's JavaScript console, usually F12 or Ctrl+Shift+I, then enter window.debug_geom equals true. After this, interact with the simulation, e.g., use the controls or slider. The console will show detailed logs about the shaft's angle, position, and other geometry values every frame. To turn off logging, set window.debug_geom equals false. No page reload is needed, just toggle the variable in the console.
Pasting is not allowed. How do I allow pasting? Why is it gaslighting me? Where's the allow pasting? I don't want to type it in.
The Allow Pasting prompt is not a button or menu item, it's a security feature in Chrome's DevTools console. To enable pasting, simply type Allow Pasting and press Enter in the console. After that, you can paste code, like window.debug_geom equals true winky face into the console without seeing the warning. This step is only needed once per console session.
Does that does it look legit or not? Okay, can you explain the canvas real quick? The animation doesn't fit on the canvas properly. Can you tell what the problem might be?
The canvas is set to fill the available area inside the hashtag SimAreaDiv, which is 700px wide by 420px tall.
Can you check the image? Can you explain the image real quick?
Yes. Here's a quick explanation of what you see in the image. The main white box is the canvas where the simulation is drawn. The shaft, penis, is drawn on the left side, starting from the lower left and curving upward. It is colored pink/red with anatomical shading. The colored circles and lines represent anatomical features. Orange circle, bladder. Pink circle, testicle. Red/blue lines, decorative blood vessels. The cross-section inset, top right, shows a simplified anatomical cross-section of the shaft, with the two corpora cavernosa, corpus spongiosum, and urethra. The controls below the canvas let you trigger arousal, urination, reset, toggle sound, and adjust the dysfunction slider. The legend explains the color coding for each anatomical part. Currently, the shaft is positioned close to the left and bottom edges, and the angle/length may cause it to appear cramped or cut off. This is due to the fixed base x/base y and scaling logic in the code. If you want the shaft and anatomy to be better centered and always fit the canvas, I can adjust the geometry and scaling for you. Let me know if you'd like that.
Yeah, I'm trying to fix the
To make the
scaling there.
animation fit better, the best approach is to adjust the drawing logic, not the canvas size, so the anatomy is always centered and fully visible, regardless of window or device. Here's how I would adjust it. Move the shaft's base x and base y closer to the center, e.g., base x equals 35 to 40% of width.
Okay, can we try it out in the code? Okay, I'll still modify the code. Yeah, I didn't realize that debug. Oh
Summarized
no.
conversation history. I'll update the geometry logic in your simulation so the shaft and anatomy are always centered and fully visible, regardless of canvas size. This will center the shaft horizontally and vertically, add margin factors so the shaft never touches the canvas edge, scale the shaft length and width to fit within the available area, even on small screens. I'll explain the changes after applying them.
Well, that's nonsense because because of the images below. If you can explain what's wrong in the images. Hey, can you explain the images? Tell me what's wrong. So obviously the initial position of the animation is not great at all.
Here's what's happening in your screenshots and why the initial position looks off. What the images show. The shaft is not starting from a realistic anatomical base, e.g., the perineum or pubic region, but is instead floating in the middle or left of the canvas. I'll fix the code so the shaft space is always anatomically anchored near the bladder and testicle, and the rest of the geometry adapts accordingly. The base will be fixed at a plausible point, and only the shaft's angle and length will change with arousal/dysfunction. This will make the animation look realistic and connected. Here's what I'll do. Anchor the shaft base at a fixed point, relative to the bladder/testicle. Adjust the shaft's length and angle only, so the tip always fits within the canvas. Keep the bladder and testicle in visually plausible positions. I'll apply these changes now. Made changes. The code is now fixed so the shaft space is always anchored at a realistic anatomical point near the bladder and testicle. Only the shaft's angle and length change with arousal and dysfunction, and the tip is always kept inside the canvas. This ensures the anatomy looks connected and realistic, and the initial position will always make sense. Reload the simulation and you'll see the base stays fixed, with the I'll do both of your requests. Add a debug button to toggle a debug panel, like in your screenshot, that shows the simulation state. Change the animation so the shaft doesn't jump to its default position, but animates smoothly from its current state after a reset or mode change. I'll implement these step by step and explain after. Made changes. Step 1 complete. There is now a debug button in the controls. Clicking it toggles a debug panel, like your screenshot, that shows the simulation state in real time. Next, I'll make the shaft animate smoothly to its new position after a reset or mode change, instead of jumping. Made changes. Both features are now implemented. There is a debug button that toggles a debug panel showing the simulation state, just like in your screenshot. The shaft now animates smoothly to its new position after a reset or mode change, instead of jumping. Reload and try the simulation. Let me know if you want further tweaks or a step.
Yeah, so the debug panel, we need some improvement of the position and load it on by default when page loads. But also, yeah, so after the second stage, after arousal, whatever, when we click the other button, the animation is too fast. I hope it knows what I'm talking about, because to put filtered the terminology.
I'll make the following improvements. Move the debug panel to the top right corner, with a small margin, so it doesn't overlap the main simulation. Show the debug panel by default when the page loads. Reduce the shaft animation speed for a smoother, slower transition. I'll apply these changes now. Made changes. The debug panel is now shown by default and positioned in the top right corner with a margin, so it doesn't overlap the simulation. The shaft animation is also much smoother and slower for a more natural transition. Reload the page to see these improvements. Let me know if you want further tweaks. I'll address both issues. Animation is too fast after reset or state change *. I'll slow down the shaft's animation even further for a more natural transition. Urination in the default, flaccid, position doesn't look right. I'll adjust the urine particle emission so it always follows the shaft's tip direction, even when flaccid, and tweak the angle/jitter for realism. I'll make these improvements now. Made changes. Both issues are now improved. The shaft animation is much slower and smoother after reset or state changes. Urine emission is now more realistic. When flaccid, the stream is slower, more downward, and has more spread. When erect, it's more forward and focused. Reload and test the simulation. Let me know if you want further tweaks or if you notice any other issues. Here's what's happening in your attached image during urination. What the image shows. The penis is in a flaccid, non-aroused state, the shaft is short, wide, and angled downward. The user has pressed the urination button, so yellow urine particles are being emitted from the tip. The urine stream appears to fall almost straight down, with a wide spread and low velocity. The bladder and testicle are visible, and the debug panel shows is urinating, true and a growing particle count. Why the urine looks like this. Flaccid state physics *. When the penis is flaccid, the shaft points downward and is less rigid. The code intentionally makes the urine stream slower * lower initial speed, so particles don't shoot far. More downward *. A downward angle bias is added, so the stream falls almost vertically. Wider spread *. The stream is less focused, with more random jitter, to simulate the less controlled flow of a flaccid penis. Particle system *. Each urine particle is emitted from the tip, with its own velocity and gravity applied, so the stream quickly falls and spreads out. Visual result *. The urine appears as a short, wide, downward falling spray, which is anatomically accurate for a flaccid state. Why it looks not great. Realism versus clarity *. The simulation is prioritizing anatomical realism. A flaccid penis cannot direct a strong, focused stream, so the urine falls downward and spreads. Visual overlap *. Because the shaft is short and close to the testicle, the urine may overlap with the testicle or base, which can look visually crowded. Particle accumulation *. If you keep urinating, many particles accumulate at the bottom, which can look messy. How to improve, if desired. Make the urine stream slightly more forward, even when flaccid, for better visual separation. Reduce the spread or increase the initial speed a bit for clarity. Fade out or remove old particles faster to avoid visual clutter. Let me know if you want to tweak. Summarized conversation history. Yes, I understand. You want the shaft to droop even more, point more downward, when flaccid and urinating, so the urine stream looks more natural, like the penis is angled further down during urination in the flaccid state. To achieve this, when the user clicks urination and the penis is flaccid, not aroused, temporarily increase the shaft's downward angle for the duration of urination. After urination ends, smoothly return to the normal flaccid angle. I'll implement this by adding a urination angle boost state variable. When urination starts in the flaccid state, set this boost to a positive value, e.g., plus 25 degrees. In shaft geometry, add this boost to the angle only if urinating and not aroused. Smoothly interpolate the boost back to 0 after urination. Let's make this change. The change will make the shaft point further downward during urination in the flaccid state, so the urine stream looks more natural. Here's how it works. You are correct, the code in your current file has not yet been updated to make the shaft point further downward during The patch tool is still failing due to the file's size and structure. To ensure you get the update, here is exactly what to change in your code. 1. Add to your state object, after mouse, x0, y0 inside.
Okay, I will finish this next time. You'll have two versions, so check which one is working better. And everything we do is available on BioniChaos.com. Go check it out, provide your feedback, and I'll see you next time. Bye.